right, and we're live. Okay, so let's get this homework review out of the way, and then we'll get to the quiz review, which is the thing you really want to do. So, we did the first page together last time, so that should be a skip, right? Anybody need any pens to grade? I'm gonna walk you through it while we do stuff. Anybody else that I can throw a pen at with permission? Nobody? You would have been fine. Your reaction time was great. Okay. So question: what kind of shape is this? What kind of polygon? Octagon, our favorite, right? Dr. Octagon. All right. So there it is. It has 8 sides. Octa, right? What do we know about these sides? That one's 5. That one's 5. That one's 5. I can count those, right? What about these guys? The ones that go in an angle. They're also 5. Why are they also 5? Nope, not all octagons have to have the same sides, right? I could extend those. Why? Why?
And you count the sides as 3 and 4, and then that makes the other side 5.
So we have a 3, 4, 5 right triangle here. 3 squared, 4 squared, add them together is 25. Root it, we get 5. So Pythag, right? So Pythagorean theorem is going to be the same for all of these because that's 3 here and 4 there, 4 and 3, 3 and 4. So those are all going to be 5. So every single side is congruent, which is nice, right? We have an equilateral octagon, if you're interested. Equilateral, equa means equal. Lateral means side, right? Like the Latin term for side. So all the sides are equal. However, the angles are not. So this is not a regular octagon. If you look at the angles here, they're going to be different between here and here. And the way we can prove that is if you look at this triangle, right? We have a 3, 4, 5 right triangle. This side is 3, yeah? And this side is 4. So this angle right here opens up into a 3. So that's going to be a smaller angle than the angle that opens up into the 4, right? Makes sense, right? The bigger that side is, the more we have to open up our angle, right, to accommodate for it. Now, if that angle is different than this angle, I know that this angle right here and that have to add up to what? What should those add up to? 180, right? So pick a number that's not this guy. So let's call this guy, I don't know, 30, right? So that means this is 150. Well, if this isn't 30, then that can't be 150, right? It's got to be something else, right? If that's 25, well, then it's got to be 155 here, right? The only way for this to be 150 and that to be 150 is for those angles to be the same, and we know they're not because the sides are different. So this is not a regular octagon, but it is a convex octagon, which is all I needed to know from you, right? Convex, not concave. A couple ways to test it. One, extend the lines. Do any of the lines go inside the figure? No, they don't. Another way to think of it is if it's convex, or I'm sorry, if it's concave, the angles on the inside here, there should at least be one that's bigger than 180 degrees, a reflex angle, right? Now, none of these are bigger than 180. Because if it was, like here, right, that's 180. That's smaller. That's 180. That's smaller. That's 180. You see how I'm extending these and why that connects back, right? If we extend those out and we have bigger than 180, then they're going to end up going inside the figure, right? So this right here is a convex octagon with perimeter 5 times 8, which is 40. How you feel? Deece? You feel what?
I got 200.
200. I'm interested. How?
Well, I said all the sides were 25.
Ah, you forgot to root.
Yeah.
That's why. You gotta, right? It's the Pythagorean theorem. A squared plus B squared equals C when you root it, right? Minus 1. One of these days they'll catch on YouTube. One of these days they'll catch on. All right, number 3. Convex or concave? Concave, right? And if you look, we have a reflex angle here. Look at that bad boy. Concave. Also, it extends inward. That's one way to tell. But sometimes you get shapes and it's not as easy to spot that, right? So it's good to look for those reflex angles. That's bigger than 180, right? Definitely bigger than 180. So we have concave, right? And what kind of I want to say quadrilateral. It's not. What kind of polygon? 1, 2, 3, 4, 5, 6. Hexagon. The 6-sided one, right? Now for the sides. 1, 2, 3, 4, 5 here. That's like our favorite number for this assignment. If you notice, if I take out some blue and I make a right triangle here and here, well, that's 3 and that's 4. So what is this length here? 5, right? It's a 3, 4, 5 right triangle. This mirrors it. Another 4, 3, right? Another 4, 3, another 4, 3. So those are 5 as well. So guess what? We have an equilateral hexagon, although it is not regular, right? The angles on the inside are different. Like that one is not the same as the rest. So we have 5, 5, 5. 5 times 6 is 30. That's the perimeter. Questions, comments, concerns? Yes.
What happens if they didn't give the shape?
They didn't say hexagon?
Yeah.
-1. Turn the page. Number 4. What polygon is this? Parallelogram, which is a type of what? 4-sided figure, which is quadrilateral. Quad meaning 4. Lateral meaning side, right? Now, convex or concave? Convex, pretty obviously so. None of the stuff juts inwards. There's no cave-in, right? Again, all of those angles inside here are less than 180. The sides, let's check them out. So I can count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here. That's what I got. Is that what you got? Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, look! They're congruent. That's nice. I suppose we probably should have marked on our last diagram that these are all congruent, but whatever. Now for these guys. Let's do Pythag. Right here looks like 12. Yeah? Okay. And here looks like 5. Now, is that a special right triangle? Are we going to get a 13 here? Or are we going to get something weird? Let's find out. 12 squared plus 5 squared, all rooted. Does it get us 13? We get 144 plus 25. That's going to be 169. Nice. Which is 13. Nice. I make all my assignments myself. So we have, once again, an equilateral quadrilateral. Convex. So they're all 13. 13 times 4. What's 13 times 4? Better question. What's 10 times 4? 40. What's 3 times 4?
12.
Add them together. 52. 26 would be 13 plus 13. Is that what you did?
Oh, yeah, that's what it's called.
There are 4 sides in a quadrilateral. Minus a half.
No, I just...
Minus 3/4. Minus 1/5.
And every single one of them I only put a few sides.
I'm sorry. All right, for this one, that's a 2. That's a 3. That's a 1, 2, 3, 4, 5. Yay, 5. We love 5s. Okay. So now we got to go find the other ones. Pain in the butt, but we're going to do it. Right here is a 3 by 4. So what does that mean this is? A 5. This one's a 3 by 4, so that's a 5. This one right here is a 3 by 3, so that's going to be 3 squared plus 3 squared rooted. That's 9 plus 9 rooted, so that's root 18, right? So this is root 18. Here we have a 3, 4, right? So that's a 5. Here we have a 4, 3, so that's a 5. And I think that covers all our sides, right? Yeah, I think it does. All right, so starting here, let's add them all up. So we have 3 plus 5 plus 2 plus 5 plus 5 plus root 18 plus 5 plus 5. That's what P is. Okay? Let me zoom in. All right, so 1, 2, 3, 4, 5 5s. How much is that? 5 5s? 25. 25. All right, and then we have 3 and 2, which is another 5. So really we have 30, right? And then plus root 18. Done. Don't plug that into a calculator. Why would you do that? It's done. It's as simple as it gets. It's like having 5 plus x. You can't combine them, so just like leave them, right?
What's the name for this one?
The name for this shape? Oh, great question. So how many sides do we have here? It looks like 1, 2, 3, 4, 5, 6, 7, 8 sides. So what kind of shape is that? That's an octagon. Remember, octagons don't have to have all equal sides. It's not a rule. It's just they have to have 8 sides. Now, this is not a regular octagon by any stretch of the imagination. It's not equilateral. It's not equiangular. Is it convex or concave? Concave. Here's our reflex angle right there. Right there's the cave-in. Beauty. Now, pop quiz. What if this side right here wasn't 5 and it was root 18? How would we write that answer? Well, first of all, it wouldn't be 30 anymore. I took away 5, right? So it'd be 25. Can you see what's going on here? You can't see what's going on here. Here. Okay, so what I did is I scratched out that 5 and made it root 18. Okay? It's not, but let's pretend it is. So now I've got this, 25, right? Because I took away 5. And then I have two root 18s. So when I do plus, I've got root 18 and root 18. Is there a way I can condense this further?
Can you put root 18 squared?
Not squared because they're not being multiplied, right? Think about it. I had 5 5s, so I got 25, right? If I had 4 5s, I get 20. Well, I've got 2 root 18s. How do you think I can write that? 2 root 18s.
18.
Huh?
18.
It would if I was squaring them. They're not multiplying, though. They're adding, right?
Square root of 36.
Good thought, right? Maybe you can add them up like that. Turns out you can't. If you type it in your calculator, it will come out to something different.
All right.
But it's a good guess.
2 parentheses square root of 18.
I won't do the parentheses, but you're absolutely right. It's 2 root 18s. It's 2 times root 18, right? Just like if I had 10, I could write that as 2 times 5, right? Well, I've got root 18s, 2 of them. So it's 2 root 18s. 2 5s is 10, 2 root 18s is 2 root 18s. Okay? Now that's not the answer for this one. But if you were to see that on, I don't know, your review packet, which means you might see it, I don't know, on your test, you'd need to combine those. If there were 3 of them, you'd write a 3 here. Okay? It's adding, not multiplying. I like that we came up with the 2 common answers that people give, right? They think, oh, root 18, root 18, that's regular 18, right? Because we're squaring it. Not quite. We're adding them, right? That's multiplication. And then the other thing was adding them up when they're already inside the roots and get root 36. That'd be nice, because what is root 36? 6, right? When you add those up, you're not going to get 6. You're just not. And I can prove that to you right now. So, root 18, is it bigger or smaller than 5? How do you know it's smaller?
Because 5 is 25.
Yeah, root 25 is 5, right? So that's got to be smaller than 5 because this is root 18, right? Root 25 is bigger than root 18. So it's smaller than 5, so root 18 is between 5. Now, what about the next square number we know? 16, root 16. Is that bigger or smaller than root 16? That's bigger than root 16, right? It's root 18. So it must be between 4 and 5. So somewhere between 4 and 5. Let's add them together. We do twice that, right? So maybe it's 4.5, right? Maybe it's 4.5. We do twice that, that's 9. That doesn't get us 6, does it? There's no way a number can be between 4 and 5, and we double it and get 6. So root 36 does not equal 2 times root 18. Or I guess I should write it like this. And I just proved it. Not possible. Root 18 is between 4 and 5. A number between 4 and 5 doubled is not going to get you root 36, which is 6. Right? Questions, comments, concerns? Other than for my mental well-being. Fantastic. I like this class. Last page. Draw an example of a convex regular pentagon. Here it is. 1, 2, 3, 4, 5. And I'm telling you, all the sides are the same. And I'm telling you, all the angles are the same. Now, look at this. Are those angles the same? No, you silly goose. But I said they were. So they are. Done. Some of you guys are busting out the protractors and going to town here. If you wanted to bust out the protractor, we have 5 angles, right? And we need all angles to be the same. Turns out, ladies and gentlemen, the internal angles of any polygon, always add up to 360. Always. What's 360 divided by 5? 72, you said. So all those angles have to be 72 degrees if they're all equal. That's kind of dope. 7. Can you have a concave triangle? Why not?
Because there needs to be more than 3 sides for it to go.
Or more than 3 points, right? If I have 3 points, how many different ways can I connect them? Well, I can connect them like this. Can I connect them in a different way? No, right? Is that concave? No. So it's impossible. There's only one way to connect them, and it turns out it's convex. So no. That's kind of cool. But as soon as we have 4 points, we have multiple ways to connect them, right? Right? No, we still have one way to connect them. So what's the difference? I led you astray. Can we have a concave quadrilateral? How? Draw me an example. Michaela, come up here. Can you catch? She can't, but it's okay. We're live. Have a seat. Teach the class. You tried so hard. Like, you can handle that.
Oh, wait, never mind.
Yikes. Never mind.
Yeah, I added a side.
Oh no, we added another side. Can anybody draw a concave quadrilateral? Give it a shot. I did the same thing in my brain when I first tried this. I love that you did that. There's something very human about us all. Except for me. Whoa! Is that a polygon?
No.
Why not?
No.
It's got curves.
Yep.
We're body positive in here, but we're not allowed to do that. Sorry. Can we draw a concave quadrilateral?
No.
Bo says no. Now, it's easy to be someone who says no, because it's impossible to improve it for every possible thing, right? For the most part. There are mathematical ways to do so. So you just sit there and you say no. So we need 4 points, right? There's 3. Concave or convex? Let me draw it bigger.
Yes.
Yes, perhaps. How about I draw it like this? Remember that shape the other day from the square problem?
No. Yeah.
Sitting in the square, it was green back then. Concave or convex? How do you know it's concave? If you were to extend this line out, it'd go through the figure. Another way to think of that is this angle right here is a reflex angle, right? So while there's only one way to connect the points up, that's not what matters, right? It's can we produce a reflex angle on the inside here? Now, I told you that when we make any polygon, the internal angles have to add up to what? All these internal angles have to add up to what? 360, right? So when I make a triangle, I've got 3 of these guys. I need a reflex angle in here to make it concave, don't I? Reflex angles are what? Bigger than. So I need an angle. Let's call it angle A. Has to be greater than. That's so confusing. 180 degrees. I lied. Not every polygon's internal angles add up to 360. There's one exception. Triangles, even if they're different, all the angles always add up to 180. Always. 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 I've been lying a lot today. Yeah. Sometimes that happens. My first rule is trust no one. That includes me. Second rule is always have a plan to kill everyone you know. Okay? They add up to 180. So can one of the angles be greater than 180? No, right? Because it has to equal 180 with all the others. If one's bigger than 180, we already, blackjack, we busted, right? So it's impossible. That's fun. Self-development, anyone do it? Great, fantastic, awesome. If you did, great. If not, write it down and turn it in later if you want. Put a grade on that. If you love it, put it in the bin.
How many points is that?
Oh, 2, 4, 6, 8, 10, 12. Let's make it out of 12.
Okay, but when I was, so like, for all of these, I didn't add like all the sides.
Yeah.
Would that just be half of it?
Let's take one.
That's what I did.
All or nothing. If you want to fix it, fix it.
I mean, I only missed.
But if you fix it, you don't miss any. But you could fix it like right now. Are you guys catching on to this? Like you can literally fix it the minute we're done. Right? Right? Homework isn't real. Yeah. Snoop Dogg? What's your favorite song by Snoop? Anything with Dr. Dre is good. So we're talking like
Yeah.
Early snoop, like doggy style. All right, well, not today, kids, but soon. We will listen to Snoop. I know I get complaints that we don't listen to hip hop in here, and like it's definitely true. We do not. A lot of that is because most of the good stuff is hard to play in a school setting, right? It's not that I don't like it. Trust me. It's time for the review. I need a soundboard, like where I can press a thing and like an air horn goes off, or like we have like a review music or a Jeopardy theme. It's gonna happen eventually. Chloe, why are you so awake this morning? Do you have lots of coffee? Did you get sleep? You must have. There you go. The R on the side here means it's the review, because notice at the top it says it's the test. It ain't. What happens is I make the review, and then I take the review, and after I print it and save it, I save another file and call it a test, right? And then I cut down the problems from the test and then change the numbers, right? Or cut it down from the review and then change the numbers. I forgot to put a heading on this one, and so when I put the heading on it, it was test number 1 instead of test review number 1.
What is this? What's the R for?
Well, we just got done explaining that, Bo. You can watch the video.
Oh, okay. I wasn't.
It's okay. I'm not mad. I just don't want to say it all again.
You're good.
All right, thanks, bud. So that's the review. It's a lot. Now, you'll notice, okay, that this is basically just all your homework stapled together with your quizzes. Yeah, it is. Some of the numbers are different, some of them are not. You guys aren't smart enough to notice anyway, right? So, here's what we're going to do. We're going to play a little game. We only have so much time. No, we're not playing an actual game. Relax, okay? We only have so much time. We're not going to do all of these. We never do all of them, right? This is not for a grade. This is for your health, right, Steve Brule? Which ones do you really want to see? Yeah, Jenna.
I want to see the number 4.
Number 4 is a hot item. All right, number 4. We need number 4. Anybody else have a nomination? Yeah, Lainey. 2. 2. Everybody loves 2. All right. Any others? Jen already voted. Bo.
All of them.
All of them, no. But a great attempt at humor.
13.
Definitely the funniest thing I've heard all day, which is a very low bar. 13. All right, 13. Yeah. 6. Good choices. I'm guessing you don't want to see 7 or 8?
No.
All right, would you rather see 2 or 5? Or I'm sorry, 4 or 5? I would imagine 5, right? That's the one with the section?
Yeah, 5.
Right, midpoint, 1 to 1, Jenna, is just midpoint. Add them up, divide by 2, right? Okay. Yeah. 13. 13 it
I
is.
already called it.
Oh, you already got it?
Yeah.
Okay, then we already have 13. Okay, do we need to see any of them on this page? Any of the ones on this page?
Maybe 12.
Feeling okay? Notice there's some variables here, right? So you're going to have to solve for x. When we find DAE, the way we're going to do that is note that I tell you that CAF is 85. So this is 85. Subtract these 2, right? Divide by 2. And you get what x is. Smell what I'm stepping in? Set it up, knock it down. All right, here we go. Number 2. Let's do that one first. No one wants to see number 3? Do we feel like we know what we need to do for this one?
We have no.
Okay. I'm going to go through it real fast. It won't take long. So number 2, here's the setup, okay? Check it out. This guy and this guy added together should get you the whole thing except what? They give you a little bit extra. See how this counts, this middle part? Right? That includes the middle part. See how this guy counts the middle part as well? So we counted that middle part twice. So here's how we account for that. Okay, we say that x plus 7, that's this guy, right? All the way across. Plus the other guy, 11x minus 2. Okay, that's going to equal 13x minus 3. But we added this middle guy twice, right? So to account for that, we need to subtract that. Are you smelling what I'm stepping in here? Okay, this thing and this thing overlap, so we need to subtract one of those middle guys. That way we don't count it twice. And now we just go to town. Get our x's together. Terrible idea in real life, great idea in math. On this side, we have 12 x's minus 3 x's. Well, it's going to be 9 x's, which is a lot. 7 minus 2 is 5. So now that I've condensed each side, now let's get our x's together across the way, right? I subtract 9x from both sides, and I get 5 equals 4x minus 3. I add 3, I get 8 equals 4x. I divide by 2, and guess what? X equals 2. Now, what did they want us to find? CD. CD. That's this guy right here. Now, we know what x is. What we need is a way to write CD as an expression. Something with an x in it, right? So we can plug it in. Well, check it out. 11x minus 2 is this much. Right? If we want CD, what do we need to subtract? BC, right? Subtract this guy, right? Take the whole thing here, subtract that, we get this. So that's going to be 11x minus 2 minus 3x. Well, that's just going to be 8x minus 2. Well, what is x? So we have 16 minus 2, which means it's 14. How you feel about that? Like, you're rushing to write this down, right? And that's adorable. Yahoy. Russian. Do you see the logic? That's the real point. Are you seeing the show? Don't be bogged down writing this stuff, okay? If you want, screenshot it when I'm done. Save yourself some time. Watch the magic, okay? Or go home and watch it later. Number 3. All right, so here's what it says. Start with the Pythagorean theorem. So step 1, start with Pythag. What's Pythag? Nailed it. So that's Pythag. Call it what it is. Work your way to the distance formula. Okay, so what we need to get there is we need a bunch of different points on our diagram. So I always start with the bottom left one. You can do whatever you want. I'm going to call that my x1, y1, because that's where I'm starting, right? Now check out this next point. The point across from it, to the right of it. Are these points the same horizontally? If I'm moving horizontally, are they the same? No, they're different, right? One's sitting at like on the left side, one's sitting on the right side. So they're different horizontally. So they have different x's. Because x is the horizontal value, right? Are they the same vertically? Yeah, they are, right? They're sitting on the same, same ground here. So if that one's a y1, that must be y1 as well, right? Now what about this point up here? Let's compare these two. Are they the same horizontally? They are actually, so they have the same x, right? But are they the same vertically? No, they're on different floors. This guy's on the ground floor, this guy's on the top floor, so they have different y values. So if that's a y1, that has to be a y2. You smell when I'm stepping in? Think how they're different, right? Think how they're the same. So that has to be it. We don't know what x and y are on the coordinate plane because it's not on a coordinate plane, right? But if it were, we'd know that this would be different in that way and this would be different in that way. Now we know that A, which is the vertical part here, right, is going to be the difference between these guys. Why is it the difference between things? Differences, distances, what? Subtraction, exactly. So we know if we subtract the x's, what do we get? What's x1 minus an x1? 0, right? Goes away. What's y2 minus y1? Well, it's y2 minus y1. So we know A equals, in this diagram, y2 minus y1. This is different than your quiz because I had A on the bottom for your quiz, right? Doesn't matter where A and B are. They're interchangeable. But if A's up here, it's the vertical part, isn't it? So we say this because vertical distance, right? A is how long that is, so it's the vertical distance. So the y values, distance is subtraction. And we know that B is x2 minus x1 because the y's go away, and all that's left is x2 minus x1. And that's because not vertical distance, but y? Horizontal distance. Okay, I need that. That's the explanation right there. And now that we have that, we can do substitution. That means to switch stuff out, right? So instead of a squared, I'm going to have y2 minus y1 quantity squared. So something squared plus something squared equals c. I'm going to root now. What am I plugging in for a in this one? Can I, oh, I'm sorry. Is it better if it, oh, I guess it is zoomed out all the way. How's that? Okay. Thank you for telling me, Lainey. So in this diagram, instead of writing a and then squaring it, what am I going to write instead of a? y2 minus y1. Do not write x2 minus x1. Don't get in the habit of a is always that. That's not true. On this diagram, a is the y's being subtracted. And it's okay. Do something, square it, then add it to something else, right? We're just adding. Doesn't matter which order we do it in. It'll end up being the same formula. And the b's are the minus the x's in this one, right? Because it's horizontal distance. And again, I'm not going to ask you on the test, how would things change if A and B were switched? You just need to be aware of that, right? If I switch those two, these two would be switched, right? A would be the x values and B would be the y values. Just be aware of that. How do you feel about that? Do you feel like you could pull that off? Nail the points. Think about how they're different. Start with Pythag. Get the distance. I need this. That's the explanation, okay? All right. Number 4, we're going to skip. Number 5. What I'll try to do today, I have to leave today after school. I'll be here for probably a couple hours, but not a ton, which means I won't have a lot of time to get stuff done. I'll try to do the entire packet in one video so you can watch it at home. I'll try, but I can't promise that. For number 5, it says what we need to do is use distance formula, and we need to also find the section. Okay, we can do distance formula on a different problem because there's other ones for that, right? You wanted to see that one weird-looking shape. So let's just do the section formula, but you need to do distance if it asks you to, okay? So let's do section. Section formula says we need an m and an n. Remember, that's our ratio. Well, in this problem, m is 5, right? Because 5/7. What's n going to be? Yeah? 2. Not 7, but 5 and 2. Because if I have 5/7 over here, I must have 2/7 over there, right? So it's 5 versus 2 is what we're doing. So the formula is, can you guys all see this? Yes? Okay. We add them up and divide by the number of pieces, right? Well, how many total pieces are we going to have? 7 total pieces, right? That's where that bottom number comes in. Right, midpoint formula, if it's 1 to 1, total number of pieces is 2, so we divide by 2. This one we're going to divide by 7. We've got 5 pieces of this x and 2 pieces of the other x. We've got 5 pieces of this y and 2 pieces of the other y. Now, remember, section formula is very particular. Do we do the x2s first or the x1s first? It's misleading. The x2s. Okay? You start with the second guy. So here's x1, y1. Here's x2, y2. So x2 has to go first. Yeah, zoom in some more. There, that's visible, right? Here, x2 has to go first. Has to. So we have to put the 1 there, not the -6. You dig? You're going to make that mistake tomorrow. x1 goes next, right? We have the average of the x's, comma, the average of the y's. So now it's the y's turn. We do y2 first. y2 in this problem is what? -8. And then y1 is -1. Then we just do algebra, right? Or really arithmetic. 5 times 1 is 5. 2 times -6 is -12. That's all over 7. Then we have -40 minus 2 over 7. Reduce that, or not reduce that, condense that down. 5 minus 12 is -7 over 7. And -42 minus 2 is -42 over 7. What does that reduce to? -1 divided, comma, negative, close, 6. It's all right. How embarrassing. No one cares. It's fine. All right. So plot your points. -1, 2, 3, 4, 5, 6. -1, that's A. Always label them. B is 1, -8. 1, 2, 3, 4, 5, 6, 7, 8. Connect them. Draw your point in. -1, -6. 1, 2, 3, 4, 5, 6. And if I drew that line straight, we'd be good. Could you do distance formula if I wanted you to? Right? Add them up. Subtract the x values, add them up to the y values after squaring, then root. Wonderful. Next one, midpoint formula. Number 6. All right. Endpoint number 1 is -3, -2. Midpoint is 1, 5/2. We're looking for endpoint number 2, right? So normally when we do midpoint formula, we have midpoint equals the average of the x's, the average of the y's, right? But here's the deal. We only know one set of our x's and y's, right? The other one we don't know. That's what we're looking for. They give us the midpoint, so the midpoint is 1, 5/2. And that's going to equal the average of the x's over the average of the y's. Well, we only know one of our x's and one of our y's. Which x and y do we know? This guy and this guy, right? Our 2 endpoints normally go here. Trying to find the middle of 2 endpoints, right? So we know the -3, and we know the -2. But we don't know the x and y here. That's what we're looking for. So now what do we do? Well, that's the x value of our midpoint, right? and it's supposed to equal this. So write that. 1 should equal x minus 3 over 2. Now we also know that this should equal this. So write that. 5/2 equals y minus 2 over 2. And now you solve. To make a better world, the first thing we do is find the division and get rid of it, right? So let's move over that 2. How are we going to get rid of that 2? How do we undo divorce? Multiplication. So we multiply. We get 2 equals x minus 3. Therefore, x must equal 5. Now over here, got to get rid of that division, right? So we times by 2 to both sides. What's 5 divided by 2 times 2? 5. Then we add 2, and we get y, therefore y equals 7. So our coordinate, our missing endpoint, is 5, 7. If we don't get through all these guys, it's okay. I'll try to do it better with my other classes, okay? Because they'll choose different problems. So you can watch their thing, even if I don't make a comprehensive video at the end of the day. Number 13, although this is the last one, isn't it, that we wanted to see. All right, first of all, concave or convex? Concave, they all said, because it goes in, right? See how we have a reflex angle here? See how those lines would cut through the middle if I extended them? Right? If it's pointy, it's usually concave. Okay? Pointy is relative, though, so you got to be careful. How many sides? 8, so it's an octagon. Review the notes, that way you know. Like watch the video that we did the other day that goes through all the different polygons you need to know names for. Okay? Not all of them are going to be octagons and hexagons and pentagons. You also need to know quadrilaterals. You got to know dodecagon or dodecahedron and a decagon as well, right? 10 and 12. Dec is 10 because December is the 10th month of the year, and dodec is 12 because it's do, 2, and dec. It used to be, actually. That's the joke. So now we got to find the side lengths so we can do the perimeter. Well, check it out. That's a 3, 4 right here, so that's 5. That's 5. This is a 3, 4, 3, 3 right here, it looks like. Did I do this right over here? 3, 1, 2, 3, 4. Yeah. So this is a 3, 3. Everybody see this? How that's 3, 3? 9 plus 9 is 18. Root it. Root 18. Now over here, that's a 3, 4. You got to be careful, right? That one looks like it should be congruent, but it's not. It's actually smaller. This is a 5. And we got these stupid guys over here. 6 and 2, yeah? And they're identical, I think. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Oh, nope, this is a 7. So we have a 6 and 2. Let's do this in our heads. What's 6 squared? What's 2 squared? So that's 40, right? Add it up. So we have root 40. This one over here. 2 squared is 4. 7 squared is? Add them up, we get 53. Root 53. So they're not congruent. Now we have all our sides. We have 5. I'll do it here. 5 plus 5 plus 5. Oh, we don't have all our sides. We're missing some. Check out this guy. 3 by 1, yeah? What's 3 squared? What's 1 squared? Add them up. Root 10. Again, 3, 1, so that's root 10 here as well. So we have 5 plus 5 plus 5 plus the root 10 I missed, plus 7 down, plus root 53 down here, plus root 40, plus root 18, plus root 10. It's a lot of roots. That's okay. It means less work for you. So I counted 1, 2, 3 5s, 1 root 10, 2 root 10s, I should say, 1 root 18, 1 root 40, and 1 root 53. So that's 3 5s. That's 15, yeah? I have 2 root 10s. How do I write that? 2 root 10, right? And then I have root 53, and root 40, and root 18. Now, if you want to go bonus points, root 40 can be reduced. I can think of root 40 as this. Bonus points, because we have time, right? Not necessary. Let's break down 40 into prime factors. We have 2 and what? 2 times what is 40? 20. 2 is prime, yeah? Keep breaking down 20. 2 times 10. Keep breaking down 10. 2 times 5, and now we're all prime. So another way to think of root 40 is 2 times 2 times 2 times 5, right? That's 40. 2 times 2 times 2 times 5 is 40. There's no way to write it. Now square root says if you have squares, you get to remove them. Well, that's a square, right? That's 2 squared. So he gets out. Do these guys get out? Nope, they stay inside. So we have a 2 root 10. So technically, this is 2 root 10s. So how many root 10s do we actually have? 4 root 10s. I'll accept either on the quiz tomorrow. We haven't been over square roots in here. I haven't told you my jail story. Okay? We'll get there. How you feel? Do you feel like there's no way you're going to pass this thing? Yikes. Here's the deal. If you did well in quiz 1, then you shouldn't have trouble with these. You might have had trouble with this, but now's the time to get it, right? Now you know. There it is, in all its glory. Midpoint. Come on, guys. Add them up, divide by 2. We can do this. Add up your x's, add up your y's. Distance formula, you better know it by now. Section formula can be tough, right? You mix up your x's in what order they're supposed to go. Remember, second x comes first, second y comes first. M and N are 5 and 2 here, not 5 and 7. I see that all the time. We're dividing by 7 because that's the total number of pieces. This one's kind of a toughie, doing midpoint formula backwards, but it doesn't have to be. The setup is the key. I only know one of my x's, I only know one of my y's, so I plug those in. The other ones I leave blank. This part equals that part, go to town. This part equals that part, go to town. Okay? Naming angles. Pretty easy, right? Probably not going to be on the test. I don't remember if it is or not, but remember, if it's easy on the review guide, it's probably not going to make the cut. I try to make your test short, that way you have plenty of time to do the stuff I really need to see. Especially if I can test that somewhere else. Hint, hint, hint. If you don't know how to name angles, there's no way you're going to do this, right? I bet I thought that last night when I made the exam. I don't remember, but I bet I did. And then using distance formula, which is really Pythag. If you get lost on this, because there's so many drawings all over the place, okay, raise your hand tomorrow. Let me help you decide what's going on here. Because I almost counted 7 as one of the sides when really the side was this, right? Let me help you, okay? I know drawings are hard. I want to know if you can do Pythagorean theorem more than anything. And that's it. If you can do this entire packet, A+, guaranteed. If you can do most of this packet, well, if you can do 80% of this packet, you're probably getting 80%, right? Study tonight. Make sure you can do this thing. Okay, it gets you a head start if you bomb it, right? Because you got to complete this anyway. And it's going to let you know kind of what you're getting yourself into, which is always good. It doesn't have to be hard. I feel like this one can be easy if you know what it means, right? It should just flow out of you. Label the points, write Pythag, write distance formula. Maybe you have it memorized by now, maybe you don't. I don't, I'll be honest. I just think of Pythag in my mind and replace it. You should be able to figure this out from the diagram. Think. Don't memorize. Section formula. Okay? See if you can do this on your own at home. Give yourself some fractions and see if you can come up with a ratio. Let's do that right now. If I gave you a fraction of 3/4, that's a 3. What's the m and the n? 3/1, right? 3/4 here versus the 1/4 left over. That's how you have to think of it, okay? How many total pieces are there? 4, right? Okay. What if I gave you 5, I already gave you 5/7. How about 12/34? Well, that reduces actually to 6/17. So we can think of it like that. It's 6 versus what? 11. Total pieces is 17. Right? Get your M and N's right. Make sure you do X2 first, Y2 first. This one, again, the setup. I know you guys are confused about this, but it's not so bad. Write your midpoint formula. Average of the x's, average of the y's. Plug in the x and y you know. That's equal to that. That's equal to that. Knock them down. Okay? It does not have to be scary. If you need some extra help, I will be here after school today for a couple hours. Then I got to drive to DeKalb. Okay? I'll see you guys tomorrow. I believe in you all. I do. Knock this out of the park. Destroy it. Remember how it made you feel on quiz 1 and quiz 2. Never let it make you feel that way again. Murder it. And its family. It's the only way people learn. As an educator, I feel like I can say that. Good luck the rest of the day. Hang in there, okay? Goodbye. Go away now.
I thought that was an hour.